Uh, First, again, my apologies for Monday's disastrous lecture. That didn't go very well. I did post some pre-recorded lectures on exactly the same material to Kaltura and to my Google Drive. So all of that material is there. If anyone has any serious questions about it, I'd be happy to entertain them. I'm not going to go back over it today because we actually have a rather large and serious topic to cover this week, the particle system. And so I'd like to actually get started on that, and I'm going to share screen unless there are any immediate questions. And I can't see chat. Okay, so I'm going to share screen here and close this up. Park this someplace here. All right, so I want to talk about the particle system. Because this week's assignment is to make a particle system. And there are lots of free particle effects on the asset store. I'm going to quickly show them here, and you'll have to forbear me as things load, because I think the problem that I had on Monday was that I had loaded too many Unity instances. So I'm just going to load them here. So these are the standard asset particles that you get, and this is that little demo scene for the particles. Things like fire, there's a mobile fire, a dust storm, steam that you can make come out of different things here. This one's a nice one, the water spray that you can actually knock things down with. There's flares with electric sparks and stuff going on. And of course, there's explosions for blowing things up. These are similar to the demolition, the detonator pack. Those are particles as well. And so this is just what comes with standard assets. And if you load the asset store package, you get these sample scenes that have this in it. There's an older Unity particle pack, 5X. And here's where we have to wait while I load these things. With this older stuff, there's sometimes some fiddling. The 5X comes with post-processing that you actually have to remove what they send you and upgrade it. But this has a bunch of nice particle effects as well. Of course, explosions, big and small, fancy blue explosions, some really nice fire effects, a flamethrower, a torch, smoke, sparks, electrical sparks. Notice some bouncing, rain effect, storm clouds, dripping water, a nice waterfall with splash where it hits the surface, a whole bunch of bullet effects for shooting things that leave marks. You can, I like this one. This is dust. This is shooting bullets into sand. And of course, we can shoot holes in containers and make stuff squirt out of it. There's, of course, blood splatter, if you're into that sort of thing, rocket trails, all kinds of stuff, dust motes. You can't see them on this screen, sand, and we're back to explosions again. So that's this one, the 5X pack. And finally, there's kind of the queen of particle packs. There's the Unity particle pack. This one may take a little time to load. And this has everything that you could possibly imagine in it and more. And it's big, so it takes a lot. So this kind of provides you with the shopping store here, where you can walk down these corridors and see all these different effects. And if you stand in front of each one of them, a little sign comes up that tells you something about the effect and how it's done. But there's just a full shopping store of particle effects. Here's a bunch of these bullet things, like we saw in the 5X pack. There's these fancy swirling effects that we'll actually use later when we get to teleportation. We'll actually figure out how to use some of these. And there's this whole list of particle effects that come standard with Unity. All you have to do is download the package and you've got them. And they're all prefabs, and they're all easy enough to use in your own project. That said, in this coming week's assignments, what I will be grading is the particle effect that you make, not the particle effect from one of these systems that you add to your scene. I'll be looking for original creations from you guys. So I'll load this one and get it going. So what we're talking about here is the Shuriken particle system. There is actually another particle system, the Vfx Particle System. It's completely different. It only runs in a programmable render pipeline like the universal or the high def. And so I'm not going to speak about it. I'm only going to speak about the Shuriken particle system. And as you could see, you can make clouds and steam and fire and explosions and so forth. There are a number of different tools that we have to speak about that are used a lot in this system. This includes things like the curve editor, colors and gradients, the gradient editor, the particle system inspector, the various modules that the particle systems come with, and how we can combine individual particle systems into particle effects, these kind of unified systems of many particle systems that work together as a particle effect. Shuriken is, I think it's Japanese for sword hidden in hand, and throwing stars that the ninjas use are shurikens, and so it's interesting that they named their system. Shuriken is far and away one of the best examples of a TMO, a too many options system. There are, I think, 24 properties that you have to define for a particle system, defined within 22 individual modules that we can use to modify the behavior of our particles. Each of those modules have between 1 and 24 options. So lots and lots of options. And with this complexity comes great power, of course. So the first tool I want to look at are the curves. Now, a lot of the properties that we define with the particle systems describe how properties change with time over the lifetime of the particle. When we make particles, we give them a certain lifetime, and the min-max curves in general are describe the change of that value over time. Now, the simplest is, of course, the constant. We give it a constant value. It's uniform over time. But we also have the opportunity to make it random between two constants. So we can specify a constant of 1 and a constant of 7, and its behavior will be random between those two. But we can also define these curves, and we can actually have it be random between two curves. So we can get very wildly different behavior with these curve definitions for these different properties. So a curve looks like this. It has these keyframe points, which you can add and subtract and manipulate. It has a number of presets for curves. It has an amplitude here that you can set in the inspector. If we have random between two curves, we define the two curves, and it will choose a curve that is between these two. So it won't be one or the other, and it won't jump back and forth between them. It will kind of define its own smooth curve somewhere in that region. So pretty cool stuff. In the curve editor, we think of the x-axis as time between 0 and whatever, and the duration property of our effect, or the lifetime of our particle, depending where we're doing this. And the y-axis, of course, is whatever the property is, and you can adjust that range of the property in the little inspector. So the curve editor, we can have multiple curves showing at the same time. Here's a curve for a three-dimensional property, something that has X, Y, and Z values. And so we can have a different curve for each of the different ones. If we make a very complicated curve with a lot of keyframes, one of the things you can do is optimize it, which will reduce it to a parabola, basically 3 keys define a parabola. As I said, properties that describe vectors. We have a triple min-max curve, which is simply curves for X, Y, and Z dimensions side by side. You can manage a lot of curves in the editor, and you can actually make a curve editor window that you can dock like any other window. So you can have this curve editor available in one of your saved layouts. Now, the other tool that is very powerful is the gradient. And here's an example where we're defining color over lifetime. And as with the other properties, you have the choice of a constant, or I believe you can also do random between two constants. This would be between two different colors. But we have the gradient that will describe the color of our particle over its lifetime as it moves from when it was born to when it dies. And here in this example, they have random between two gradients. So it's going to choose a color between these two different gradients. And so we can get very fancy with our manipulation of color over the lifetime of our particle, or over the duration of our creation. We have 2 different times that work in there. Color-based properties have a little pull-down menu where you can choose the color. You get this color picker wheel that can either be defined in terms of RGBA or hue, saturation, and value. You choose which way you want to represent color. RGB is kind of the traditional one where you specify the amount of red, green, and blue of each of the 3 different channels. Hue, saturation, and value is a little different way of representing color, but it does the same thing. These gradients will vary the color through time. We can have random between 2 colors, random between 2 gradients, and we can actually have a random color. A color is selected at random from a provided gradient. In this case, the horizontal axis is no longer time. The gradient editor looks like this. Along the bottom, we have sort of the keyframes of the color. It's red here, it's green here, it's blue here. And across the top, we have the alpha or transparency of our color. So here at the beginning, it's fully opaque. Here it's becoming more transparent. And here at the end, it's completely transparent. So this means that our particles would start off red, change gradually to green as they faded away until they disappeared gradually at the end of their lifetime. And you can add new markers, you can have as many as you want, and you can discard them as well just by dragging them off screen. These different values, when you click on this, there'll be a little slider down here at the bottom where you can adjust its value between, I think it's 0 and 255. And the same with the colors. When you click on one of these, it opens, when you click on this, it opens a color picker window where you can define the color. I'll show you examples. So the particle system is all built on its inspector. And it's a component like any other components. You see there's the transform component, and this is the particle system component. And it's within this inspector that we define the properties of our particle system. And let me turn these off here. And just to start with here, I'll make a new particle system. It's under effects and it's particle system. And I'll set its position here to be right in the center. Whoops. So here's my little particle system. It's 0, 0, 0. And one thing to notice right away is that the particles come out in the blue direction, which red, green, blue is X, Y, and Z. And the Z direction is the forward direction of our objects. So right away, if we want particles to emanate up from our system, we have to rotate this thing by 90 degrees. It does it automatically for us. We don't have to do that ourselves. Let me turn this plane off so it's not cluttering things up here. So this is the little particle system that I've made. Here's its inspector. And in the inspector, we have a number of different modules. It automatically comes up with an emission, a shape, and a renderer, and this main module that all of them get and can't be erased. The other ones you can turn on and off. Later, I'll show you some particle effects. The editor here If I open the editor, it opens a window. You can dock this window, but this is exactly the same as what one sees in the inspector, just a little more convenient place to see it. So the particle system modules, as I said, there are like 20 of these, so lots of them. And initially, we get these 3 kind of default ones, and we can set this up in different ways. We can have only the active ones visible, in which case, if we want to add one, we have to manually add it like that. And I can turn that off and it'll go away. Or we can have all modules visible, in which case the little check mark shows me which ones are active and which ones are not. For purposes here, I'm going to go back to only the visible modules are visible. So I have emission, shape, and renderer, and these are the ones that you get with the default. And as I mentioned, you can enable and disable each of those by check marks. So the main module describes the behavior of the particles, and it's permanent, can't be removed. It's the basic thing. And the main module has a number of different, it has many different things that we have to specify. One of which is the duration. This is the time that the particle system runs. And the next one is whether it's looping or not. If we have looping turned off, this particle system runs for 5 seconds and then stops. Let me restart this thing over here. So it runs for 5 seconds and then it stops. If I have looping on, it just continues. It essentially starts over again. Some of these things, some of these settings, like the start color, which by default is white. Here's the little color inspector thing. I have it set for RGB, and I can specify the different values of my different colors or move this around in whatever way I want. And here's an example where we can put a gradient in here. This gradient, and here's the gradient editor, will be the color of the particles over the duration, over that 0 to 5 seconds that the particle system runs. And these are a bunch of different presets. If you make one you like, you can press the new button and save it. I've saved a whole bunch of them here. And here I'll just pick this rainbow one. And now my particles, as they run, come out in different colors, starting at red, going through green, blue, and ending with red again. And because I have looping off, it then stops. With looping back on again and restarting it over here, it's now going to cycle through those colors and go back to the beginning again. This is a nice little tool over here. This little particle effect tool lets you restart it, stop it, play it, and adjust the playback scene so that you can make your particle effects run fast or run very slow so that you can kind of see what things are happening in here. So this is a nice little tool that is handy. And the other thing here, it shows how many particles are active in the scene with some other tools that we'll get to later. So lots of stuff. Now, I mentioned lifetime back under color over lifetime. And so we can specify a start lifetime. This is how long the particles live. And by default here, they're 5. If I make this 1, these particles don't last as long. They only last 1 second. The duration of the effect is still 5. The lifetime of the particles is now 1. And we can set their speed, how fast they come out. We can set their size. We can set rotation. These particles are actually symmetric, so rotation doesn't make any sense with them. I showed you start color. You can turn on and off whether gravity affects the particles. The gravity modifier is initially 0. If you set it to 1, then the gravity will be full gravity. If you set it to 0.1, it's kind of smaller. One that's really important is the simulation space. This determines whether the particles are simulated in the local objects, in the object's local coordinate system, or whether they are in world space. And this is going to be very important when we have moving particle systems, because if they're in local, they will move with the system. If they're in world, they will be left behind by the moving particle system. And you can, you have speed. Play on awake. Play on awake kind of populates the entire system. If I set this up to 10, now it's taking a long time for the particle system to populate. If I have play on awake set, what it does is it basically populates, well, it didn't do it. No, that's not what I want to play on awake. I want to play on awake is whether the particle system is active or whether we have to start it from a script. Whereas I don't see it. Well, oh, pre-warm. Pre-warm's the one that fills the system when you start it. So it starts with all the particles already out there. That's called pre-warm, and it does cost some cycles. Now, another thing that's important to set here is the maximum number of particles. I can have up to 1,000 here. And so if I go to emission here and say that I want to have 1,000 particles per second, this is the rate over time. Actually, I did 10,000, but 1,000 per second. What you're seeing here is that it stops emitting, and that's because I've run out of particles. So it has to wait until some of them die before it can make new ones. But you can set this up to 10,000, and now it's continuing to emit 1,000 particles per second. So lots and lots of settings, and those are all the settings of this main module that determines kind of how things start off, how particles come into existence. Now, the other modules, well, emission, you just saw, determines how many particles per second we're making. Then there's things like shape, velocity over lifetime, force over lifetime, color over lifetime, color by speed. These are all the different modules that we can add. And I'll go through some of these. The emission module has a number of different ways of dealing with things. You've seen the rate over time. So here I have it emitting 1,000 particles per second. So we're getting lots and lots of particles, lots and lots of particles. But I can also turn that off and turn on the rate over distance. So I'll say 10. And now I restart it, nothing happens until I move this thing, and then it emits particles at a rate of 10 per unit distance that I travel. Now there's an example of that simulation space. I'm in local, so the particles stayed with my particle system. If I switch to world, now the particles are left behind and leave this kind of trail behind me with all of the other properties, the color, the start color, and so forth, behaving the way I want them to. Now, the other setting for emission, let me turn this back to 0, is bursts. And I can have as many bursts as I want. By default here, I get a burst of 30 that occur at time 0. So I can set what time during that 0 to 5 second duration that the system runs. I can have the burst do more than one cycle. And I can set the interval between the different cycles. So this is making a burst of 30 particles at time 0. It's doing it once. And if I had, say, 2 cycles and I set this up to 1 second, I'm now going to get 2 bursts a second apart. First burst and then second burst. And there's also a probability that you can set for how likely the burst is to occur. With a probability of 1, it's guaranteed to, but you can set that down. I'm going to pause for a second, see if there are any questions. Okay. Everyone's good to go. Okay. So the next module is the shape. Here are all the different settings for the emission. Now the shape one, this is a real TMO. This has lots of different choices. In particular, we have a choice of the shape, what the shape is. And there are lots of different shapes. There's spheres, hemispheres, cones, donuts, circles, volumes, lots of different shapes. And each of those shapes has different settings for it. So the cone, for instance, has the angle that it emits from the radius of the base of the cone, the radius thickness, whether we're doing the full cone or whether we're just doing some portion of the cone, the mode, whether it's emitted randomly or systematically, lots and lots of settings, as well as position, rotation, and scale of that shape. So lots of different settings. Let me shut this down. Well, let me go back to emitting 100 of these things, and I'll turn off the burst. So here we are emitting, and I believe by default we came up with a cone. We have an angle of 25, and over here in the scene view, you can see that little cone, which you can adjust if you can grab the gizmos. I'm not able to grab the gizmos. If you can grab the gizmos, you can adjust it there. But I can also adjust it here, changing the angle of that little gizmo. The radius of the base, you notice it has, the base is 1 unit. If I make the base bigger, that changes the shape of the cone. You can't make it 0, but you can make it rather small, so they're basically emitting from a point. The radius thickness is whether the particles come from the area of the base or whether they come only from the edge of the base. Here, our little particles are kind of coming straight out along the edge of my cone here. And then the mode is random, loop, ping pong, or burst spread. And I'll let you play with different settings to see what they look like. This is a real playful tool. You can play with things. Now, as I said, there are other settings. There's the sphere. So now our particles are being emitted from a sphere. Up here, we had the start speed, which is how fast they're going as they're emitted. And so these are now being emitted at 5 meters per second in all directions from our sphere. And this has a radius and a thickness and an arc and a mode spread and all these other settings for the sphere. A hemisphere is just what that says, a half sphere that emits kind of in the forward direction. But we have, well, I did the cone. We have donuts, boxes, meshes. So you could actually put lerps in here and it will emit from his mesh. Skin mesh renders, again, that would be what you'd use for lerps. Sprites, circles, edges. This is a line that is where the particles emit, and a rectangle, a square in space, that is where the particles are emitted. So many, many choices for how particles are emitted, the shape of the object from which they're emitted. So I'll stick with the cone here, and I'll make the base kind of small so that they're emitted from a point. So that's the shape module. All the different settings of our particles. Now, we have a lot of different over lifetime settings. And here's one where you can set the velocity of your particle over lifetime. And this is one of these ones that is a vector because velocities have X, Y, and Z components. And again, these can be constants or they can be curves. And we also specify the space. Orbital velocities are how they're going to rotate around the different axes. And so we can do fancy things here. Let me shut these up a little bit. And I'll add that velocity over lifetime. And I'll just make the X velocity 5. So immediately they're blown off to in the X direction. Remember that we're emitting in the Z direction. So I think if you want the Z direction, no, it's Z in the world. That's because I'm in space local. If I'm in space world, then Z is now, that's in the world, it's Z. Here in the local, Z is the blue arrow, the forward direction. And of course, you can get real fancy with all of these. Here's orbital X of 5, so that's rotating about the X axis. And all of that's pretty cool. Noise is a handy one to make your particles look realistic. This uses Perlin noise. It has options for having different noise in the X, Y, and Z directions. With Perlin noise, we have the frequency, which is kind of what the wavelength of the Perlin noise is. And we have how many octaves we're going to use. Perlin noise is discussed here, but with a noise module activated, our particles are now getting their noise from this kind of Perlin noise thing. If I set more octaves, it makes the noise kind of more granular. And I believe you can actually make this thing move as well. Here's the scroll speed. So if I scroll this, the noise kind of scrolls through the Perlin noise world. And so our noise is very, very random. And we can, of course, set this up so that it does with this differently for the X, Y, and Z axes of our little entity. Limit velocity over lifetime. My particles aren't affected by gravity, but if I did have them affected by gravity, they would go up and then fall and accelerate under gravity. Limit velocity over lifetime is a way of kind of imposing drag on the particles so that they don't get moving too fast. Let me close that up. So if I turn on a little bit of gravity here, where's gravity? 0.25. So my particles now are being pulled up by gravity. I have a nice little fountain going on here. And if I wanted to, I could limit the velocity over lifetime to some value so that they never fell too fast. Somewhere down here, they're falling really fast. And so limit velocity over lifetime. Inherent velocity, this is something you use with the emission over distance. How much of the particle object velocity is inherited by the particles that are emitted from it. And you can go from 0 to 1. 0 is, it's not going to inherit any of its velocity. 1 is it's going to inherit all of them. Force over lifetime, I won't do an example of this, but this is just says what it does. It applies a force to the particles over the lifetime. And so you can make fancy X, Y, and Z applications of force on the particle over its lifetime. And this, of course, uses the curves. And in this example, they've got random between two curves. Color over lifetime is an important one. We used the gradient up here with the start color, which is changing the color over the duration of the particle system. And let me set this back to white. Whoops, I don't want that. I want to set it back to a constant color, and I want it to be white. So color over lifetime is a really important one for no other reason that it's important that our particles don't pop into existence. So my particles here, as they spray up into the world, let me make the lifetime 1 so that they're dying quickly. You notice that they're popping out of existence. And so if I add a color over lifetime, I already have it, color over lifetime. And if I do nothing else but add an alpha stop here, and alpha goes from 0 transparent to 255 opaque. And I set this one down to, whoops, I deleted it. If I set this one down to alpha 0, this means that my particles fade out with time. And this looks much better. Particles that pop out of existence is bad. It kind of destroys the immersion of things. And you can do the same thing with the beginning of the particles. You can also set them to come into existence gradually. So our particles no longer pop into existence and pop out of existence. And so that, at the very minimum, is something that we would do with our particles. And of course, I've got all these different presets that I've already built up. This little rainbow, red, green, blue set of colors with different alpha values so that my particles have color over a lifetime. Very important one, color over a lifetime. Now, there's a number of by speed modules. And one thing to remember is by lifetime and by speed are mutually exclusive. You can't use both. So color by speed is now going to set the color of the object based on how fast it's going. So with that little fountain example, let me make some gravity here, 0.25, and set the lifetime back up to 5, and turn off the color over lifetime and turn on a color by speed. And in the color by speed, I need a little gradient. Let me use this one. So now when they're moving slow, they're going to be kind of orange. And when they're moving fast, they're going to be kind of yellow. And if I set the angle down here so that they're going straight up in the air, set the angle to 0. So they're going straight up in the air. You notice at the top, we have some orange ones. We can set the speed range to say 0.5 here, 0.1. So that didn't help, did it? So the colors vary with speed. And it takes some fiddling to get this to look right. But anyway, color by speed. Reminder, speed and lifetime are exclusive, and we have size over lifetime, and we have size by speed. This sets how big our particles are. We have rotation over lifetime, which with these axially symmetric particles doesn't really do anything. But if we had a particle that had some shape, they would rotate, and we can rotate by speed as well. We can apply external forces. This is the wind in Unity. Either wind zones, which we can set up, or force fields that we can set up. There's a collision module. Particles collide with the world. So let me turn that plane back on here. Back in my particle system, I'll add a collision module. Add a collision module, and I'll have it collide with the world. And it's a little hard to see this here, but the particles are now bouncing off the world. The particles are colliding with the world and bouncing off the world. And so you can have them collide. And there's some other settings that I'll talk about collision next time here, because I'm out of time. But there are more modules. There's triggers that you can have callback functions that do things. You can have sub-emitters, which is where we can make a particle system instantiate other particle systems. We can have texture sheet animation. We can have lights. We can put lights in our particles. We can have trails. Our particles can drag trails behind them, and custom data. I don't know what that is. And finally, the renderer, which is the one that one of the default ones that comes up. This is where you specify the particle that you want to show. So this is where one would add the different particles in addition to the default ones. And I'm going to stop there and stop sharing here and entertain any questions. Lots of material, TMOs, lots and lots of different stuff that we have to do, but lots of power. Now, with your assignment, as I mentioned, for this week's homework, what I will be grading is the particle system you make, not the particle system prefab that you got from somebody else. So you have to make an original particle system yourself. That said, it's fine to use textures and other kind of objects that you find in these different things. There's some really nice textures for flames and clouds and steam and other things that you're welcome to use. But you do have to make your own particle system. Any questions? Let me see if there's anything in chat here. For the assignment, do you want us to incorporate the particle system into our terrain or start a new project? You can do it in your terrain if you want to, but certainly in the creation of your particle system, it's nice to do it in an empty scene where there are not a lot of things distracting you, and you can then prefab the particle system and move it over to your terrain world. I tend to create in a kind of empty world and then prefab it, and then you have the thing to use wherever you want to. That answer your question, Mr. Brin? Yeah, you're still here. Okay. This is really a fun tool. I mean, you can have a lot of fun with this one. So I expect to see some creative endeavors here. And try and do something other than a campfire. I'm going to stop recording at this point.